So once again, you are welcome to today's class. In today's video, we are going to learn about product rule, how you can apply product rule in solving differential equations. So normally the product rule is a rule that we use when we have two functions that are multiplying each other. If you are given two functions that are multiplying each other and you are asked to differentiate, we normally use the product rule. So the rule, before we actually use it, let's understand how the rule works. So the rule is given as this. If you have a function f of x given as u multiplying v. So if you have two things, u multiplied by v, and you are asked to differentiate, so this is going to be the differentiation. This f prime means differentiation. So the differentiation of this kind of function, the rule states that you are going to write v as it is, then you differentiate the u function, which is the u dx, then plus you now write the v function, and then you differentiate v with respect to x. So this is the rule, the product rule. Okay, if you are given a function, you keep v constant, then you differentiate u, then you now keep u constant the next thing, then you differentiate v. So let's take an example so that you understand how it is actually used in a more better way. Okay, so let's take at least an example. So let's say you are given a function f of x is equals to x to the power of 4 multiplied by exponential 5x. So let's say you are given a function like this and you're asked to differentiate. Now from this one you can see that there are two things here. First we have x to the power of 4 and then we have exponential 5x. And if you are going to differentiate this function, that's when you are now going to use product rule, because you have two things multiplying each other. So this first one is going to be your u, while this second one is going to be your v. So normally the first one is going to be your u, then the second one is going to be your v. So let's apply this formula now, this product rule formula. So we are going to have f of x, which is the differentiation, is going to be, so it will say that we should keep v as it is. So this is v, so just write exponential 5x. The next thing is that we differentiate u with respect to x. So we are going to differentiate, this is u is x to the power of 4. So we are going to differentiate this one. If we differentiate x to the power of 4, it's going to be 4, and that's going to be multiplied by 4x to the power of 3, because you are going to bring down the power, which is 4, then you subtract 1 from the power, which is going to be 3, to 4x to the power of 3. So we close the bracket plus. The next thing we are going to do now is we write u. Well, our u is what? X to the power of 4. And then we will differentiate v. So v is exponential 5x. Now, if you are differentiating exponential 5x, there is something you need to know, okay? If you are differentiating exponential 5x, so what you do is you differentiate the power. The power is 5x. If you differentiate 5x, you know you are going to get only 5. If you differentiate this 5x, it's going to give you 5. So now you write 5 after you do, which is the differentiation of the power. Then you write that same thing as it is again. So you write 5, then I write exponential 5x. Do you understand? So the rule is that if you have exponential u, what you do is, if you are differentiating, you differentiate the power, which is the same thing as u prime, then you write that same exponential u. So that's what we just did here. We differentiated the power. If we differentiate 5x, it's going to be u as 5, then you write that same power as it is. So if we differentiate exponential 5x, is going to be 5 exponential 5x. Okay, so now we'll multiply these times. So we are going to have 4x to the power of 3 times exponential 5x, then plus 5x to the power of 4 exponential 5x. Okay, so this is the answer. But from here you can even be able to factor out exponential since we have the same terms here, but you can also leave it like this as the final answer.